Welcome to another GCBASIC demonstration. This is part 2 for the PIC18xxQ24 series. This is going to sequence the LEDs. We're going to show you how. Okay, like and subscribe, watch the video all the way through, let it run. Those metrics are important. So this is tutorial number 2. This is going to make 4 LEDs flash in sequence. Pretty simple. And I'll show you how you're going to do it. So GCBASIC, open source compiler for PIC AVR's LGTs, supports these chips. So I'm going to assume that you've got the software installed. I'm going to assume you've got your basic programmer installed and you've gone and tested it all works. I'm going to make those assumptions because that's fair. It's only fair that we do that. And what we're going to do is we are going to make some LEDs flash. And those LEDs, I'll put my pin, are attached to port B, to port 3, 2, 1, and 0. And there's 4 LEDs attached here. And they're attached via some resistors. Otherwise, you'd just blow the chip up. But I've got power, programmer, and some resistors attached. I'll show you my board in a moment, okay? All right? But what we're going to do is we're going to do this. We're going to initialize the system. We're going to set one LED, have a delay. We're going to rotate a variable that's called LED. And if it's equal to 4, means it's done it 4 times, it will reset it and just do it again. It's going to go around in a circle like that. And so, we're going to look at how we rotate the LEDs with a delay. It's going to introduce a variable. It's going to introduce the rotate command and some simple logic. So, recap where we were. We left it at where I could see the chip. And this is my PIC18 application that I'm using. You can use for any application you like to program the chip. I don't care, as long as you can program it automatically. And if I can see it because I can erase it, I can do things in it. Okay. So let's get out straight into GC code. I've assumed that you've started GC code and that you've got it working. And if I can remind you, that's where we left it last time. I'll go into Zen mode straight away so you can see it all. Oh, that looks slightly different. Oh, there we go. That's where we left it last time. I've got an LED flashing on and off, and I'll just press function key F5 and I will just reflash the chip for us. And that's a little dialog window that pops up. But it's the compilation, assembly process, and the download process. And in those few milliseconds, it actually takes about 3 seconds, it's flashing an LED. And that's where we left it last time. It was flashing. So I'll go to full screen and just walk you through what I'm pressing. So I'm going to close down this bottom window to get it out of the way. Top right hand or Control B to open up the Explorer view. Select 40040, rotate the LEDs. And I'm going to be really honest before I carry on. I didn't write this code. I asked Copilot to write it. Copilot is a Microsoft AI engine, and I wrote this. My question was, write a GCBASIC program. I'll zoom in so you can see it. This is obviously incredible. Write a GCBASIC program for the Q24 to rotate the LEDs on these particular ports with 100 millisecond delay, and it gave me a lump of code, which is exactly what's in that black window. And I copied that and pasted it in. Now, there were some tweaks to it I had to make because it had different constants. But to be quite frank, I can tell Copilot to change those constants. So we wouldn't even have to change it. Please use LED as the LED prefix. And it was because I've been using LED D, and there you go, he's just changed it to LED D. So that code I just cut and paste in. Let's walk the code inside of here so we can all see it. We've seen this before. This specifies the chip. Option explicit. I've changed the frequency to 32. I can delete that. I can set it to whatever I like. It doesn't really matter for this demonstration. Option explicit means I need to declare my variables. This is my hardware setup. The green is comments. These are my 4 constants, LED 0, LED D1, 2 and 3 are on ports B0 to B3 respectively. And then I set those to outputs. I'll delete that. All 4 have been set to outputs. And the rest of the program truly came from somewhere else. I didn't write it. Let's walk the code, see what it says. It says create a variable called LEDs and set that to a byte value, because we can have bits, we can have bytes, we can have words and longs, and we'll see all that generate later on. And it basically sets the variable LED to 1, number 1. It's the same as saying 1, it's the same as saying 0, 1, but the clarity that Copilot put in says, I'm going to be addressing 4 bits, which I like. I like that a lot, okay? I do like that. And then it said, because to be honest, I would have used a way more complex method than what they're using. This is so simple. It then says, initialize a counter for rotations, and it's going to rotate this thing 4 times and then reset everything back. Rotate count equals 0. Then there's a do loop, so it does the main loop, backwards and forwards, backwards and forwards. And I just noticed that it's even using the forward slashes on the comments. That's Copilot's learning quite quickly. It says the following: output the current state to the port B, and it set it to lat B, and lat B is equivalent, is the latch of port B, and that is the right way to do it. So it's still attached to port B, but it's the latch, and it latches those LED state in. And as we know, to start with, LEDs, the variable is set to 1, therefore it will set the first bit, and then it rotates that variable. If you want to know what that is, press function key F1, but it rotates the LED to the left, simple, and it just shuffles the bits in the variable LEDs, small s, to the left. So what was bit 1, if bit 0 was set, bit 1 is set. And then if it was bit 1 was set, it moves it to bit 2. And then it says, I've done 1 rotation. It then says, if rotate count is greater than 4, reset things back. Rotate count back to 0. Wait 100 milliseconds. Now, I've just pasted it in here. I didn't test it. But so what we're going to do, we're just going to bring it down a bit so we can see all the code. There we go. That's all the code. Is it all the code? That's all the code there. On there, we're going to press function key F5, make the hex, and rotate things, program it. Four LEDs flashing with a rotation and with a delay of 100 milliseconds. So GCBASIC has set the frequency, set the ports for you. It's calculated the correct delay required for the 100 milliseconds at the correct frequency. So if we change the frequency of the chip at the top here to 1, I think that's valid for that particular chip. I'll show you how you can check all that out later. It will then recalculate all the delays for you, and it will still flash it every 100 milliseconds because it's used enough intelligence, has enough intelligence to do that sort of thing for you. I'm done. That's it. I used Copilot to write code. All you need is the experience to make it all happen. I'll put that back as it was. Nice program. It uses a couple of variables, but do you know what? That's not a bad thing. We got plenty of RAM in it. We got plenty of RAM in this chip. I would have done it slightly differently, way more complex. Nice and easy method to do it. Back to PowerPoint. Next time, we're going to set those LEDs to represent the value of an ADC. So we're going to read an ADC value that's on that board. And we're going to set the LEDs to that value. So we've already gone from an LED on to rotating LEDs through variables, and all the rotation commands, because we now know they're all available. We'll go to ADC, and we'll see if ADC works. With that, enjoy.